Hello. In this clip, we are going to continue our discussion of the consumer's choice, but this time we'll assume that preferences are not standard. That is, we have some kind of extreme case of the relationship between the two goods. This could be perfect substitution or perfect complementarity. The standard way of the solution, that is using the optimality condition, which is nothing else than the ratio of the marginal utilities being equal to the price ratio, will simply not lead to a solution. The reason why this solution will not be possible, that either in case of perfect complement, we have a utility function which cannot be taken first derivative of. It is not differentiable. That is, you cannot calculate MUX and MUY, you cannot calculate the MRS. Or, in case of perfect substitution, we shall see that the utility function is linear. Now, linear utility function means that MUX and MUY are just constants. Now, there is no guarantee that this constant marginal rate of substitution will be equal to the price ratio, which is determined by the market mechanisms. So, it will be more likely that simply this equality may never hold. Nevertheless, we have to find a way then to find the optimal choice even when this standard method does not work anymore. We are going to show that the utility function, in case of perfect substitution, is going to be linear, just like this one. And under perfect complement, we are going to have a non-continuous function, a minimum function, which will also lead to some very special indifference curves. So when we have perfect substitutes, the indifference curve is a line. When we have perfect complement, then we are going to have L-shaped indifference curves. First, we look at the case of perfect substitution. Two goods are called perfect substitutes when they can satisfy the very same need. That is, from the perspective of the consumer, they are identical. It is possible, though, that you need to consume different quantities of them in order to achieve the same increase in your utility. We shall see this through three examples of goods being perfect substitutes. A first example could be that you have two types of coins. You have 10-cent coins and 50-cent coins. If you wish to make a payment of, say, €1, then you can either use two 50-cent coins or 10 10-cent coins, or basically any combination of them, for example, one 50-cent coin and 5 10-cent coins, as long as these add up to €1. The utility function, hence, is going to be just a linear function. Here you can see that having one 50-cent coin is going to give you 5 times the gain, the utility, of the gain which you have from having a single 10-cent coin. So, we get U equals X plus 5Y. And, as I told you before, the marginal utilities in this case are just constants. The marginal utility of X is 1, and the marginal utility of the 50-cent coins, Y, is 5. The marginal rate of substitution, which is going to be the slope of this indifference curve, in this case indifference line, is constant, minus 1/5. Second example could be that you can buy milk, a homogeneous good, in 2 packs. You can buy them in a 1-liter pack or in 1.5-liter pack. Now, obviously, 2 1.5-liter packs is going to give you the same increase in utility as 3 of the 1-liter packs. So, in this case, we can see that the marginal utility of a 1.5-liter milk must be 1.5 times that of X. This gives us, again, marginal utilities being constant, leading to minus 2/3 as the marginal rate of substitution. That is, in this case, the indifference curve will be a line with a slope of minus 2/3. A third example could be when the very same good can be bought from different suppliers. For example, 1 kilowatt hours of electricity is going to give you the same utility independently whether you buy it from firm X or Y. In this case, therefore, the utility function is just simply U equals X plus Y, where the marginal utility of both goods is 1, so the MRS must be minus 1, so the indifference line is just a minus 1 sloped line. Of course, for the consumer's choice, the price ratios will also matter, but no, in this slide we only looked at the utility functions. We look now at the consumer choice when we have perfect substitutes. As we saw in the previous slide, linear utility function leads to a linear indifference curve. We continue the second example where you can buy milk in either a 1 liter or a 1.5 liter pack. But now we also assume a certain budget constraint. We assume here that you have 6 euros to spend on milk, and the price of a 1 liter pack is 1 euro, and the price of a 1.5 liter pack is 1.25 euros. The budget constraint, hence, can be written as 6 equals X plus 1.25 times Y, which, once you get the Y on the left-hand side, is going to give you the budget constraint lines equation, which is Y equals 4 minus 0.8 X. The indifference curve can be calculated from the utility function again by getting Y to the left-hand side, and this will give us U minus X times 2/3. So what we can already see that the budget constraint line is going to be a line with a slope of minus 0.8, and the indifference curve is going to be a negatively sloped line with a slope of minus 2/3. That means that the budget constraint line is going to be steeper than the indifference curve. Let us draw the budget constraint line first. If you spend all your money on 1 liter packs, you can buy 6 of them. If you spend all your money on 1.5 liter packs, you can buy 4 of them. And connecting these intercepts gives us the budget constraint line. The indifference curve can be drawn for different utility levels. As they are flatter than the budget constraint line, you can see that the only way how you can achieve the highest possible utility level with given 6 euro budget is to choose to consume only 1.5 liter packs. So we will have a corner solution. This will generally be true. The only way how it cannot be true would be if the ratio of the marginal utilities, that is, minus MRS, would be exactly equal to minus the price ratio of the two goods. So when the two lines were having the same slope. But there is no guarantee that it will be so. So in general, we will always find a corner solution. But this is not surprising. What we did here is something you could have already guessed. Simply, the consumer chose the good which gives you 1 liter of milk the cheapest. In this case, if you buy a 1 liter pack, then you have a price for milk 1 euro per liter. If you choose instead the 1.5 liter package, then you get the same liter of milk for 80 cents. And this is exactly why many countries have the legislation that price tags should also show the per unit price of a good in order to improve the comparability of prices between goods which are in different packaging. So in general, we can say that if the budget constraint line is steeper than the indifference curve, then the consumer will only consume good Y. And if the budget constraint line is flatter than the indifference curve, the consumer will consume only good X. If, however, the budget constraint line and the indifference curve has the same slope, then any combination of X and Y will be optimal. So there are infinite possible combinations which are still optimal. The next type of preferences we are going to look at is perfect complementarity. First, we are going to find out what the utility function is and what the indifference curves look like. Perfect complementarity means that consuming X is going to give you an extra marginal utility only if it is consumed together with some other good, Y, in a fixed ratio. An obvious example could be shoes. Now, provided you have both your legs, then you will need a pair of shoes to be able to walk outside. A single left or right shoe will do nothing. Yeah, they will do no good, so actually, in itself, a left or a right shoe will give you no utility. You will gain utility from having a left shoe only if you also have a right shoe. That is, you have a pair of shoes. Let's see how we can visualize this. We have the left and the right shoes. No, having a single left shoe will not yield you any utility. One left and one right shoe, however, will give you a utility level of, say 1. If you buy another right shoe, however, will still give you the same utility level of 1 because one of the shoes will be superfluous. So, if you keep the the left shoes quantity at 1, then even if you increase the number of right shoes to infinity, you will still get the same utility. And this is represented by the straight indifference curve. You can also, of course, have 2 left shoes and only 1 right shoe. But again, this will still lead to the same level 1 utility. The only way to get to level 2 would be to increase the quantity of the shoes by 1 for both left and right shoes, and this would give you a utility level of 2. And we can already guess that increasing only the number of one of these shoes, so either left or right shoes, will still not improve your utility. So the marginal utility would be 0 in cases when you do not consume the goods in the given fixed ratio. And to have a positive marginal utility is only possible if you increase your consumption of X and Y in that given fixed ratio, which is here 1 to 1. It will be important for us to find the line which connects these elbows because, and I can tell you that already, the optimal choice must happen at the elbows that is along this particular line. Now this particular function is a so-called minimum function. So these L-shaped curves can be written as a function which takes the minimum of either X or Y. So let's assume that we have X equals 1 and Y equals 1. Because both has the value of 1, the minimum of them is also 1, and we have utility level 1. If, however, I increase the number of right shoes by 1 with keeping the left shoes at 1, then we would have x equals 2 and y equals 1. But the minimum of 2 and 1 is 1. So we still have the same utility level. Let's look at the second example. Sculptor needs to make bronze. So bronze, what is bronze? It's an alloy. It's made up of 90% of copper combined with 10% of tin. So unless the sculptor uses exactly this ratio of the metals, then it will be a substandard metal and cannot really be used. So indeed, now we have a fixed proportion of the two goods. We then try to visualize this. So 9 units of copper together with 1 unit of tin is going to give me utility level 1. Utility level 2 can be achieved if you use 18 units of copper with 2 units of tin. And this is going to give us a utility level 2. That is, now you can see that the elbows are along a line with a slope of 1/9. So, in this case, the minimum function can be written as u equals the minimum of x over 9 or y. That is, y equals x over 9 is going to give you this line connecting the elbows. How can I see that? Well, elbows mean that the minimum of x over 9 and y are the same. So x over 9 equals y must give you the equation of the line which connects all these elbows. Now we look at the consumer choice under perfect complementarity. Let's look at this visualization. We have here a budget constraint line and several possible indifference curves. Now, the orange bundles are all affordable. Nevertheless, they cannot reach the highest possible level of utility. Why? Because then some of the good, y and x, will not be useful. You wasted your resources and bought too much of tin or too much of copper. The only optimal choice must be when you are using exactly the necessary amount of the two goods, and this is represented by this green point here. So, the optimal choice will always be at one of the elbows. And this is why it is important that we know the equation of the line connecting these elbows. Let's take the second example again, the problem of making bronze. We already know that the utility function is a minimum function which takes the value of the minimum of either x over 9 or y. The budget constraint we will assume is 10 equals 2x plus y, meaning that copper costs twice as much as tin, and 10 units, 10 euros are available for the sculpture to spend on these products. The line connecting the elbows can be done by taking the two arguments within the minimum function and making them equal. So we have the line y equals x over 9. So basically, we have a simultaneous equation system. We have the budget constraint line as one of the equations, and we have the line connecting the elbows as a point for optimal choice. This simplifies the problem because solving this is just simply giving us the right amount of copper and tin to buy. In this case, The sculpture should buy 4.736 units of copper and 0.526 units of tin.